Good morning students. Today in our class we are going to discuss atomic structure. Already in the previous sessions and the previous classes we know what is an atom, molecule, already we discussed those cathode rays, anode rays and the charge of the electron, proton, all those we have discussed. So in today's class we are going to start with some topics. So what are the topics we are going to cover in this video is electromagnetic wave theory, Planck's quantum theory, black body radiation and photoelectric effect. These are the topics we are going to cover in this video. Okay, let's start our session today. Okay, see here, first of all, what is electromagnetic theory? See, what is meant by electromagnetic wave theory? First of all, who has forwarded this electromagnetic wave theory? He is the scientist James Clerk Maxwell. In 1864, he has given some information about the electromagnetic wave theories, right? So what are these electromagnetic radiations? He given the energy emitted by the some source. Which type of source that is? That source which is allowing electric current through that. Even see, so the radiations coming out from that source, those radiations are called electromagnetic radiations. Like not only in the electric field, if you keep that source in the presence of electric field and magnetic field, both electric field and magnetic field are perpendicular direction, and then the source, particular source, it can be any heated metal rod or any filament in the bulb which is passing electric current through that. Some such type of sources which are producing radiations through them, those radiations are called electromagnetic radiations. These are called EMR also we can say, electromagnetic radiations. So what are these EMR? Means we have in our regular life we are able to observe some type of rays. Suppose X-rays are there. Through X-rays we are using in the medical purposes, right? X-ray is also a electromagnetic radiation, and microwave oven we are using in for cooking purpose. That microwave oven is producing microwaves. Those microwaves are also the electromagnetic radiations only. So these electromagnetic radiations we are using even in our regular daily life, and these are helpful as well as those are harmful also. What are harmful? IR rays. IR means infrared rays, infrared, far infrared, all these are the some harmful radiations which we are not supposed to see with our naked eye, or which are not supposed to touch our skin directly. Such type of harmful rays also there. See, these electromagnetic radiations wavelength, according to the wavelength we have divided the electromagnetic radiations. Which has the highest wavelength, those radiations will have the lower frequency, because wavelength and frequency both are inversely proportional to each other. So out of these electromagnetic radiations we have TV waves, infrared, UV, far infrared, X-ray, all these comes under these EMR. Okay, and out of these radiations we are able to see with our naked eye is visible radiations, because those visible waves are in our wavelength. Our wavelength is nothing but the wavelength which can see by our naked eye, that is called the visible wavelength. Okay, so out of all these electromagnetic radiations we are able to see only the visible radiations. Okay, and also these electromagnetic radiations are no need any medium to propagate. Okay, they can travel through vacuum also. Okay, next. So these electromagnetic radiations or these electromagnetic waves have some wave parameters. Okay, what are those wave parameters? See here, the first wave parameter is wavelength, which is represents with lambda, and the second one is frequency, which represents with nu. Velocity, here velocity means we will consider here velocity of light. Okay, velocity of light c, and wave number nu bar, and amplitude A, and time period t. These 6 are said to be wave parameters. To calculate the wavelength or wave number or frequency, we have a particular formulas, because see here, this wavelength means, suppose it is the wave, this is called, the distance between this height is called the crust and this is called trough. The distance between the two successive crusts or the distance between the two successive troughs is called wavelength. The distance between the two successive crusts or two successive troughs is called its wavelength. Frequency is nothing but the number of waves. How many number of crusts and troughs are coming? How many number of crusts and troughs are coming? Excuse me. In 1 second, those are said to be frequency of the waves. Frequency of the waves. What is meant by velocity? Velocity is nothing but here we are considering the velocity of light, and wave number. Wave number is nothing but the reciprocal of the wavelength, means nu bar represents the wave number, nu bar equal to 1 by lambda. And amplitude. What is meant by amplitude? Here we have a crufts and troughs, right? So the height of the cruft or the depth of the trough is called its amplitude. And time period. Time period is nothing but the reciprocal of the frequency we will consider as the time period. These are the wave parameters we are studying from electromagnetic radiations, right? See, they have some relations, because if you consider wavelength is inversely proportional to frequency, from that we can bring one relation, and velocity of light anyway. Wave number is nothing but reciprocal of the wavelength, so we can bring one one relation from that. So out of all those, here we have some of the formulas to do and to do some applications from these wave parameters. See here, nu equal to c by lambda, nu equal to c by lambda, nu bar equal to 1 by lambda, t equal to 1 by nu. This nu is nothing but frequency, c by nu, c is nothing but velocity of light. This velocity of light value will be c equal to 3 into 10 to the power of 8 meters per second, 3 into 10 to the power of 10 centimeters per second. So this is the velocity of light. Okay, so based on this we can do some applications on the electromagnetic radiation. See, all these wavelength frequency are explained based on these electromagnetic radiations, but these electromagnetic radiations are not explained about the phenomena of photoelectric effect and black body radiations. Okay, so in this video we are going to learn what is black body radiation and what is photoelectric effect also. Okay, let us see. See here, first of all, Planck's quantum theory. What is the information given by the Planck? Let us see here. In order to explain the black body radiation and photoelectric effect, which is not explained by the electromagnetic wave theory, here to explain these two, the Max Planck in 1901 presented a new theory which is called Planck's quantum theory. Okay, that Planck's quantum theory has some important points and has some important relation also. That relation is between the energy and the frequency. Okay, let us see. The radiation energy absorbed or emitted by the substance. See here, till now any energy is producing from one body, that is in a continuous manner, like even Rutherford theory also failed that electrons revolves around the nucleus in continuously. So if they revolve around the nucleus continuously, they have to lose their energy and they should fall into the nucleus should be collapsed. That is the drawback of the Rutherford. That question was not answered by the Rutherford. Based on that, Planck's quantum theory is explaining the radiant energy is producing or emitting from a body is not in a continuous manner, it is in a discontinuous manner. Okay, so that discontinuous manner in the form of small packets. That small packets are called quantum. What is that? Small packets are called quantum. So for light, quantum energy is termed as photon. So we can see, so energy is releasing from a body. Is it not in a continuous manner? It is in a discontinuous manner. That discontinuous amount of energy is called in the form of packets. Those packets are called quantum generally. But in case of light, that quantum energy producing we are considering as the photon. Okay, so he given some relation there. So the energy, the radiant energy is directly proportional to the frequency of that particular light or particular body. Amount of energy is emitted. E proportional to nu. Nu is nothing but frequency. Already this one we studied in the wave parameters, right? E proportional to nu, E equals to h nu. If you remove that proportionality constant and I will take h into nu, h is called Planck's constant. H is called Planck's constant. For h we have a different values. Let us see here. The energy of quantum is E equal to h nu. H already nu we know. What is that nu? Nu and is inversely proportional to wavelength. If you remove this proportionality constant, nu frequency equal to c by lambda. C is called velocity of light and lambda is called wavelength. So if you substitute that one here, hc by lambda, already we know lambda is equals to 1 by lambda is equal to nu bar. Wave number is nothing but reciprocal of the wavelength. So in place of 1 by lambda we substituted nu bar here. So hc nu bar. Here what is h? We said h is called Planck's constant. This h has different values at different units. Here h is E is the energy in joules. We can take that h value will be 6.625 into 10 to the power of minus 27 in erg seconds. If you take the value of h in joules, 6.625 into 10 to the power of minus 34 joule second. Okay. And also we know velocity of light 3 into 10 to the power of 10 in meters per second and 3 into 10 to the power of 8 in centimeters per second also. Remaining one already we know. Nu is called frequency, lambda is called wavelength, c is called velocity of light. Okay. This is the Planck's quantum theory. So what is the relation we learn in Planck's quantum theory? E equal to h nu. That nu we can write as hc by lambda. hc nu bar like. Okay. Let us see next one. Actually that Planck's quantum theory was taken to explain this black body radiation and photoelectric effect, right? So what is black body? See here we have a two types, ordinary body and ideal body. If you take any ordinary body, if you keep that, it cannot absorb 100% of energy or it cannot emit 100% of energy. So those are called ordinary bodies. But what is a black body? This black body can absorb 100% of the radiation and it can emit 100% radiation. So the absorption or emission will be completely. Such type of bodies are said to be black body radiations. Okay. But these black bodies are said to be ideal bodies. They does not exist. Generally whatever we see in our daily life, those they will not absorb completely or they will not emit completely the energy of radiation. Okay. That is what the black body radiation. See here, when certain energy falls on the surface of a body, it cannot absorb completely or it cannot emit completely. Completely means 100%. Such type of bodies are called ordinary bodies. But the bodies which can absorb 100% and which can emit 100% of energy radiation, such are said to be black body radiations. Okay. Let's come to the next one, photoelectric effect. This is very important. What is photoelectric effect? This photoelectric effect first observed by Einstein. Okay. Here what is meant by this? Hertz performed. Actually this photoelectric effect again proposed by Einstein, furtherly initially given by Hertz. He performed this experiment. Furtherly it was extended by Einstein. Okay. Let us see what is the thing here? If you take one metal sheet, you can observe here in this figure. So this is one metal sheet. This is one metal sheet. Which type of metal is preferable for this photoelectric effect is first group elements. What are first group elements? Means alkali metals. Alkali metals, potassium, cesium, radium. What are first group elements? We have lithium, sodium, potassium, rubidium, cesium. Francium is the radioactive element, right? So out of those, see here for example, potassium, rubidium, cesium. Out of this potassium and rubidium, cesium is the finest metal to perform the photoelectric effect, okay, because it has the lowest ionization energy. That is what the reason, okay. See here, ejection of electrons from the metal surface. If you imagine it is a cesium metal surface, okay, metal is nothing but loss of electrons can take place. That is what our experiment here. So when on this metal sheet some light radiations are passed, light rays are passed, then immediately from this metal sheet some ejection of electrons are taking place. So electrons are coming out, that is called ejection of electrons, and the electrons are called ejected electrons, and this complete phenomenon is called photoelectric effect. When on a metal sheet some of the light rays are passed, immediately some amount of electrons are ejected outside with some speed. The speed is called kinetic energy, okay. So this complete phenomenon is called photoelectric effect, and that ejected electrons are called photoelectrons, okay. Why the ejection of electrons are taking place? Okay, see here, what we observed through this experiment, when we have taken one metal sheet, when particular light rays are propagated or some light rays are fall on this metal sheet, then some ejection of electrons are taking place with certain speed, that is called kinetic energy. So before going to that, we should know 2 points. One is, see here, every metal has its frequency, means minimum amount of frequency attained by the metal sheet is called its threshold frequency. Even our humans, every human will not have the same amount of energy, right? I have some, another persons will have higher or lower, it depends on particular body, right? So the minimum amount of energy containing by that body is called its threshold energy, or minimum amount of frequency contained by that light ray is called its threshold frequency. Like that here also, this metal sheet has some threshold frequency and this light ray has some frequency. If you take this is as nu as the frequency of light radiation, and the nu naught will be the frequency of this metal sheet, then when the ejection of electrons are possible, there are two conditions for this effect. What is that? The number of electrons ejected is proportional to the intensity or brightness of light. How many electrons are ejecting depends upon the frequency or intensity or brightness of this light. More brightness you give for that radiation, or you take more intensity, that radiation has more intensity, then more number of electrons will be ejected outside, okay. If you take less intensity, then less number of photoelectrons will come outside. And one more thing, the frequency of this light radiation should be greater than or equal to threshold frequency of the metal sheet. If you take, suppose this light ray has 5 edges like, but the threshold frequency of this metal sheet is 4 edges. So compulsory this light should have the frequency greater than 4 or equal to 4. If you take the frequency of this light radiation is 3, then no photoelectrons will be comes outside, means no ejection of electrons, no photoelectric effect. So the condition is the ejection of electrons, to eject the electrons or to do the photoelectric effect, to observe the photoelectric effect, there should be the frequency of light radiation should be greater than or equal to the threshold frequency. If you take frequency of light radiation less than the threshold frequency, then no photoelectric effect will be observed. Okay. So, these are the two conditions, means so to observe these photoelectrons we have to follow these conditions. This is called photoelectric effect. Actually see, so whatever, so we have a final C here, h nu is nothing but energy emitted, h nu equal to h nu naught, nu means frequency here, nu naught is the threshold frequency plus some kinetic energy. This is called equation for photoelectric effect. Okay. So, h nu equal to h nu naught plus kinetic energy. So, this h nu means with particular radiation, if the frequency of radiation hits the metal sheet, they will eject the electrons with certain speed, that is called kinetic energy. So, overall photoelectric effect we are representing with this equation. Okay. So, which metal is the best for this photoelectric effect, means already we discussed, that is the cesium. Okay. So, this is about the photoelectric effect. So, in this video we have discussed about the EMR, means electromagnetic radiations, and Planck's quantum theory, black body radiation and photoelectric effect. Okay. Thank you so much.